In this video, we're going to use the second derivative test to find local extrema of an algebraic function. It says use the second derivative test to find the location of all extrema in the interval -3 to 9 for the function given below. So, the first thing I want to write out is some things that we know about the second derivative before we start. So, there's some definitions that we need to write out. So, if f prime or f double prime of c, when we do the second derivative test, is greater than 0, then f has a local maximum at c. Now, c is talking about a critical point. So, f double prime of c greater than 0, then f has a local maximum at c, where c is the critical point. So what we're going to do in our problem is we're going to find the critical points, and then we're going to plug them into the second derivative and see do they have a positive or a negative sign there. If they're a positive sign, then they would have this would be actually a maximum, and if they have a negative sign, then they are going to be a minimum. So we're gonna also write out some other things. Let's see, f double prime of c less than 0, then f has a local, oh, I got this backwards. This is maximum. Oops, sorry. So if f double prime is greater than 0 at that spot, that means we're concave up. That should have been a minimum. So this is concave up. And this would be concave down, this next part. Now, what happens if f double prime of c is equal to 0? Then we would say the test is inconclusive. So, we're going to start by taking the first derivative of this function. And when we do that, we bring the 3 to the front. That cancels the denominator, so we get -5 x squared. Bring the 2 to the front. That cancels the square part, or the denominator, and we end up with plus 15 x plus 20. We're going to set that equal to 0. And then I'm going to divide each piece by 5, or by -5. So we end up with 0 equals x squared minus 3x minus 4. That's going to factor to 0 equals x minus 4, x plus 1. And then we're going to do the zero product property, so x minus 4 equals 0, or x plus 1 equals 0. So we have critical points that are x equal 4 or x equal -1. So these are our critical points. Now, we're going to go through and we're going to do the second derivative test. So we'll take the derivative of this and write this as f double prime. Derivative of the first derivative would be -10x, and then plus 15. And so then, once we get the second derivative, -10x plus 15, we're going to do the second derivative test. So we're going to write down what our critical points are. And we'll kind of make a chart here. So we've got -1 and 4 for our critical points. And then we're going to say this is the sign of f double prime of our critical points. Okay? And then this is our conclusion out here. So if I take -1 and I plug it into f double prime, so I'm going to say f double prime of negative 1. I end up with positive 10, so negative 10 times negative 1 plus 15. I end up with 25. So this gives us a positive sign here for that critical point, which if we have a positive sign, that means we're concave down. So that means that negative 1 would actually be a maximum. And then sorry, that would mean, well, this is concave up. I screwed that up again. This is concave up. This is not a maximum. Concave up. So positive means concave up. That's a minimum. And then on this one, if we plug in f double prime of 4, I would get negative 40 plus 15. So I get negative 25. So that's a negative sign there. That's concave down. So this was concave up, which means we have a minimum. This is concave down. So let's write these. This would look like so, which is why we have a minimum. And this one is concave down, which is why this is a maximum. And so we have a minimum and a maximum at negative 1 and 4 using the second derivative test.